Hi everyone, so I know I've been absent for quite some time again and I apologize for that. I've been busy with all kinds of projects in the meantime, and I've also been doing a few repairs, of course, and lately I have been focusing on Sega consoles, and I feel like Sega consoles are a little bit underrated because everywhere you go you only hear about Sony and PlayStation, so there's not as much of a scene in terms of Sega stuff, specifically Sega Saturn models, and I find it fascinating how many revisions there had been released during the short lifespan that it had. In this case, I have acquired a bunch of broken Japanese models, the gray ones. I don't think they were ever released in Europe or USA. So I have been researching a lot about how to repair them and how to refurbish them essentially. And so here I wanted to show how I did it and go over a little bit over each step of the refurbishment process. So first of all, I wanted to focus a bit on the shell, because these shells, they often start yellowing or they come in all scratched up. So I wanted to test out how to restore the original or close to original surface and color, and I've been experimenting a bit with retro bright, but I feel like it just never quite worked so well for the gray variants. It works better for the white ones, but the gray, it just wasn't achieving the kind of results that I wanted, so I decided to just repaint the whole thing. And for that I used a specific paint that I found that works best for this specific color. I'm gonna let the camera focus a little bit. So yeah, I'm using this paint, Duplicolor Next Generation, and the color is ash gray, and I feel like this suits best for this particular model. It may not be the exactly the same as original, but it's still amazing how well it suits it, because on first look you wouldn't even probably be able to tell that it was repainted. I mean, of course, I'm not perfect at it yet. I'm still trying it out, and you know, I had a bit of a spot here that I accidentally touched, but otherwise it ended up looking surprisingly great. And this paint, it doesn't even need the varnish that you usually have to put after the main paint, but I still tried to experiment with that as well. I got this satin lacquer, and this has also worked quite well, and it has to be this premium one, because the other ones I tried, the cheaper ones, they just kept, you know, they just didn't work so well. I felt like they were coming off constantly if you even touch it a little bit with wet hands or something. It just wasn't staying, it wasn't sticking so well. But anyway, this satin lacquer I put here, I tested it with this surface specifically, and it seems to have added even more of that slight glare. Probably, again, it may not be the same as original, but I feel like it's even better than original in some ways. And I've also tried it on the controller. My camera, I got a new camera and it's struggling with focusing, so I still need to adjust it. But anyway, here's probably the best paint job in the experiments that I've been doing, because once I got the paint, it sprayed it perfectly, and there was no spots, no nothing, no bubbles. And I also applied varnish on top, and I had no issues with that at all, because it almost got sprayed perfectly on the first try, and as you can see, the results are perfect in my opinion. Again, the original is more glossy, but this is what I had on hand, so I decided that it's a good alternative. Of course, you can compare it. If you compare it with the original, I can show you right here. Here's the original color, and here is the painted version. And you see the original is a bit more glossy, but it's also more scratched. And there's a little difference in the shade of gray, but it's also hard to tell, has it already begun to yellow, for example. I believe that this is perfect fit for it, for the gray revisions. Of course, I've also wanted to show you my experiments with the disc tray cover. So here's the original, again, kind of scratched up and hard to tell, like, has it begun to yellow, but I guess if you look under it, the underside of it usually is the one that is not yellowing as much as the top side. So if you look at that and if you compare it with my color, it is actually pretty close. So yeah, and in this case I have tried to preserve the original decals, and it is a little bit tricky, I'm gonna have to admit it, because you can preserve the Sega logo. It's somewhat easy to mask off when you paint, because the font is easier to work with, but the Sega Saturn logo is completely different story. It's obviously it's a lot harder to mask it off in a way that you would also cover off the original paint. And for this I have also been experimenting with transparent printing paper, so it would be quite easy to print this logo, the black one, on that paper and just stick it. Anyways, the next thing I wanted to talk about is the fact that these Japanese consoles, they come from Japan, so obviously there is an issue with the electrical grid that they're using, because this is meant for 100 volts and in Europe we use 240. So I had to come up with a way to replace the power supply, and here's the original. So the original supply could be modified somehow to support 240 volts. There is some information online about it, but first of all, there are many revisions of these power supplies, and second of all, the guides online for the modification, they're not exactly reliable. It feels like somebody just replaces the main cap and, you know, one resistor or some other component and they think that's it. But as I began to study this further, this may not even be enough, because then you might cause the MOSFET or transistor to overheat, and basically it's just not the best way to do it. There are also some revisions of the power supplies that don't have any instruction at all on how to modify them. So basically the whole thing here was designed for 100 volts, and I feel like it's just better not to mess with that, because you may never be sure if you did it correctly or not. The power supplies are somewhat complicated, and you need to know what you're doing before you start messing around with these components here. So I came up with a way to just replace it with DC buck converters, and I figured that this would be the easiest way, because these little things, let me show you, they're very cheap. I got them from AliExpress. I know that it's not the most reliable shop, but I have tested these things and they work just fine. I paid about €1 or something for each, and it's using quite reliable microchip controller here for the DC adjustment, and so basically it's able to drop down from about 5 to 60 volts DC on the input down to wherever it is you want on the output. So in this case, this revision of the Saturn will use 3.3 volts, 5 volts and 9 volts. So I have designed this power supply kind of holder for these little buck converter PCBs, so I could put 3 of these into each slot that was made for them, and then I will just wire everything carefully here, and I will reuse this original connector that goes onto these onto these pins here. I took it from here, from the original power supply, and yeah, because, you know, I'm just trying to do it kind of on a budget but still with quality in mind, and So yeah, this will be reused, and then I have also made proper opening on the back for the DC jack, so it will be used instead of this AC input for the regular AC cable. I will be using the DC input jack, as you can see, and for that I also bought a bunch of these plugs. So they're in fact there are specific measurements on them, so of course I had to make sure they will fit just right into this plastic. And I've also ordered a few of the DC plugs, DC jacks that will, in case the adapter that I'm using doesn't have the correct plug, I can just resolder it. And so basically this was a way to do it if you are able to solder and 3D print something like this. I feel like since I'm going to be repairing and refurbishing a lot of these, I will need a lot of these power supply conversions or power supply mods, you could say. And so this is how I decided to do it. I mean, sure, it may take more time, but in the end I'm gonna be saving more money rather than just buying the finished pre-made PCBs that you could also get from AliExpress, in fact, and they cost about 20 euros per piece. I still think this will be, in fact, in some way better quality and also probably twice cheaper. In any case, there's another important thing here. I used a filament that is not just the basic filament, but of course here I tried it with basic ABS plastic, and I suppose it would work just fine as well. But then I realized this ABS plastic is not flame retardant, so just in case something goes wrong, it's better to use flame retardant plastic. And of course it's a little bit more expensive, but at least I have better peace of mind if I'm selling some type of modified power supply inside a Sega console. I will know that just in the worst case scenario, if one of these things somehow catch fire, you know, it's very unlikely, but just on the off chance, I will know that this plastic is not gonna catch fire as well, so it will be a lot safer this way. And this is also how these PCBs are made. The official printed circuit boards, they always have a specific rating. I think there's this specific lettering, I don't remember exactly, 97V0 or something like that, which means they are flame retardant as well. But just like I said, if you're doing it for yourself, you could probably just use basic ABS plastic, and you know, if you believe that it's really unlikely that something here goes wrong unless you messed up the wiring or soldering. But yeah, this could be a great alternative for people who are able to solder and who know what they're doing, basically. So as I was talking about this design that I came up with, and obviously there are a lot of specifics I had to think about. For example, this connector here that goes to the button, I will also desolder it and glue it here, and for that I use Loctite glue, which is quite strong. Here it is. And of course I will also be using specific wires that can handle the load, and I have them right here. I got these wires from Amazon, if I remember correctly. This has to be 18 AWG, so it should be more than enough for the Saturn because it's using about 20 watts. I will show you how I do it, you know, how the final version will look like. And the reason I chose this TPS 54560 DC step-down converters, it's because they are quite affordable, they are reliable, they don't overheat, and also they offer low ripple, and I can show it to you later on the oscilloscope. So I'll be using this Huawei adapter that I found from a flea market, 12 volts, 2 amps, 24 watts in total, and it's more than enough for this Saturn. This already has a correct plug, so I don't even have to replace the plug at all. It fits perfectly into the one that I bought. And these were really cheap because for some reason, I don't know if it's like this in every country, but in Finland, if you go to a flea market store or second-hand store, there's always a box full of these adapters, and all you need to do is find the one that's rated at the correct specs. But the important thing is that it's at least 20 watts. And for example, I got this one here that just didn't work so well. I don't know why, but the Saturn kept shutting down with it. Maybe it's better to get something like 30 watts or more. Here's another example. I believe it's from a laptop. I only got it for €3 and it's where's the specs? Hold on. Oh, here. This one is definitely gonna be enough because it's rated at 59 watts. I don't know if you can see. There. Yeah, so this one will be 59 watts. Don't buy them from AliExpress because they are really unreliable. Anything that you plug directly into the wall outlet, you really shouldn't be buying from China because there is no guarantee how that would work and it might set fire. You know, I've heard news about people buying some electronics and it set on fire. But in case of these buck converters, I believe, well, I hope that there's nothing in them that could really catch fire. But just in case, this is part of the reason also that I got a flame protective filament. So next I will measure the ripple, and I will have to do it in 2 separate tests. First is when it's not under load, and then separately when it's under load. So I will have to record 2 separate measurements, and of course I will also do all the basic mods such as region free BIOS and FRAM mod. I will have to replace this 3 volts battery, and by the way, a lot of these come broken, so they also need repair. And in my case, this is probably a whole different topic, but in this case I fixed it by replacing one of the hex converters here. I don't know if you can see, but apparently these are broken quite often, and you can also measure it. The way to know if it's working well or not is to measure it with the oscilloscope, because it will show you bad signals in one of the inputs or outputs. And when this microchip goes bad, you get a black screen. So this is exactly what I had in this system. And once I measured it and once I measured this chip and replaced it, then it came back to life. Some of these revisions will also require new capacitors around the PLL chip. I believe I have the VA0, which needed that. It also had black screen issue, and once I replaced the capacitors here, then it started working again. But maybe I will go over that in the next video that I will dedicate to specific faults and the ways to diagnose them. Right, so here I will show you the original power supply ripple values, and I wanted to emphasize something here, is that I have to use the step-down voltage transformer for the 100 volts power supply, and it's extremely important that you don't plug the scope when you're using this type of transformer. You can't plug this and this into the same outlet, because it will cause some kind of a ground loop, and last time I did that, it destroyed my whole Saturn. It destroyed this power supply. It tripped my ground fault protection interrupter, I think it's called. Well, we call it, well, in Europe it also goes by the name of RCD, which is, well, it's a circuit breaker. So when I had both of them plugged into the same outlet, I turned this on, and then the moment I flipped the power switch on the scope, the power went down, and yeah, my Saturn was dead basically. So yeah, just a word of caution, be careful with this. So what we do is we have to plug the scope into the same step-down converter, and luckily it has 230 volts outlet here, and so this way it's safe to use, and this is how you measure it. So this thing is plugged in right now. First we measure 9 volts ripple, and here we go. You get 24, about 20 to 20, 26, about 25 you could say, 24 peak to peak. Yeah. Then you get, then we go to 5 volts, same thing there. It's up, it's from 20 to 30 millivolts peak to peak. It's jumping around a bit. And the same thing for 3.3 volts. So we can safely assume that the original power supply, which is not under load, will give you from 20 to 30 millivolts peak to peak ripple, and yeah, so that's what you get. I will also measure how much ripple this thing outputs, this adapter. Right, so let's continue our measurements. Right now I plugged this probe into the plus of the output, the plus wire, and I will now connect ground right here, because this is where ground is, I believe. Yeah, you have to be careful with these because sometimes they're reversed. Before you measure ripple, you have to make sure that this peak to peak value, when nothing is connected, that it's not showing you any high numbers, because I didn't realize it, but it wasn't calibrated, and so it was already showing me like 50 millivolts peak to peak even when nothing was connected. And turns out you have to self-calibrate this scope so that it resets everything and recalibrates. Let's try to see how much this adapter, Huawei adapter, how much ripple it's giving out before any DC step down circuit. Yeah, so you see it's around, okay, it's, yeah, I don't know if these peaks here, you could see those high, really high peaks, if this is just from noise or something else, but you could assume it's something between 40 and 50 perhaps. This is still when it's not under load. Okay, so now we can finally measure it with our buck step down buck converter and see if it's helping at all to reduce the ripple. And so you can see it's already smoothing it out. If you remember, it used to be 40 to 60, and now you can see this is about 7 to 9 millivolts. So yeah, it's doing a good job at removing some of the ripple. And so this concludes my test. So this concludes the measurements of original power supply and step down converter when they're not under load. Okay, so now that it has been tested and you have seen that it is working fine, then I will add some hot glue for these cables. And I know the cable management could have been better, but this is how it is right now. And I'm just gonna use hot glue to kind of keep them all in place so that there's some kind of order in here and it doesn't look so crazy. So yeah, I will just improvise a little bit. You know, it's not perfect science. I'm basically gonna do something that feels logical. I also wanted to add, especially for this connector here, obviously it won't be enough to add just hot glue, because every time we take it out it's gonna use a lot of force. So I'm gonna use this Loctite again to try and glue this thing into our plastic here, so that there's some kind of hold on it. Wow, this is leaking. Super glue and hot glue. I think I finally got what I wanted. So you can see I can lift it just like normal power supply, just like this one. And I got all the wires out of the way, and lots of glue. Oh, sorry, my cat is messing around. A lot of wires in the back, but it's okay. Point here is that it goes in easily and comes out easily. And you will also have to make sure that nothing is touching like too much of the metal, like the red wires especially. But luckily we also have this protective plastic here, and this shell, this base sits really well and nothing is like in the way. The last thing I'm gonna add is this protective clear coat for the connections which are exposed here. And what I mean is, hold on, and by that I mean all of these soldering spots for the inputs, outputs on each of the DC step-down converter. So this thing will keep the exposed solder protected, just in case. Also here. So yeah, that would give me also a bit of that peace of mind when I sell this thing to somebody else. So yeah, and of course it's better to, like, you don't want to put clear coat onto these contacts because they need to be exposed. Also this needs to be covered because, yeah, this needs to take contact with the other pins on the motherboard. But everything else can be clear coated, you could say. So just put a bit of that tape here, like so. This thing is also kind of toxic, I guess. Probably better to turn on my fume extractor for this. I also actually plan to add a tiny heatsink onto the 5-volt converter, because that's the one that takes most power, using most amps. I think it's like 2 amps that it could use at maximum. Because according to these markings, if the camera can focus here. But yeah, here it says that the power supply can supply 5 volts at 2 amps. So if any of these might produce more heat, that would be this 5-volt step-down converter. And for that, we actually should expose the microchip that's taking care of the conversion. And for that, I'm just gonna use isopropyl alcohol and kind of clean it up a bit here, so that it will be easier to add the heatsink. I'm talking about those mini heatsinks that I was also ordered when I was ordering these box. Right, obviously we need to let it dry a little bit. There. Yeah. And it came with the glue already, so we just remove the protective film and just stick this thing in on top of the IC, like so. And then you hope that the glue is good enough that it won't just come off during transport or something. There's also, it's probably a good idea to add a bit of extra glue here, so that these PCBs don't come off. If they throw around the package or something. I'm also going to put a bit here because, well, I don't trust that glue enough, but and you could say like, oh, you shouldn't put hot glue onto the heatsink, but you realize I think this melts at something like 200. So if your heatsink gets up to 200 degrees, then you have other problems. Now I'm not sure. Again, my design wasn't perfect here, so I probably won't be able to fit this spring, but I will try to at least fit the nut.